Welcome back. We're in lesson 94. We're going to talk about independent and dependent variables. So when we have a linear equation, let's say y is equal to, let's say 1/2 x plus 4. This is our equation of the line, or our linear equation, and we know we can graph this, but what we have to do first is find the pairs that will allow us to graph it. And one of the first things that we learned in pre-algebra was how to find those pairs through use of a table. And we understood that we could substitute in any value we wanted for x and thus find the coordinate pair for y. For instance, if we substituted in 0 for x, right, we knew that this b here, this plus b value, would be the value for y, would be 4. And if we substituted in, let's say, the value of, 2 for x, 2 times 1 would be 2 over 2, that'd be 1 plus 4, y would equal 5. And let's say we substituted in the value of 4 for x, 4 over 2 would be 2 plus 4, so the value of y would be 6. So the value of y was completely dependent upon what we chose for the x to substitute in. And that is why we typically consider x to be the independent, and it is independent because it can be anything. We can pick any number we want to substitute in for x. But y was the dependent because y value, or the value of y, depended upon what we chose for x. And that is the relationship here. Whatever we choose for one variable, let's say I choose for x, then the y is dependent upon what I choose for x. But you could also choose a value for y and solve for x, which would then make y the independent value and x the dependent value. It just depends which one you choose. Whichever one you choose is equal to the independent value. And the one that you don't choose, the result is going to be the dependent value. So we make a picture of this, or we draw a picture of this illustration when we make a function map. And we have a function map. We've looked at these before, where we have the two ovals, and let's say we have 0 and 2 and 4. This is our domain. And the domain is another way to say the x, all possible x values. And then the other oval would become the range, which would be all possible y values. And with 0 we had 4, and with 2 we had 5, and with 4 we had 6. And for each one of these, they have one value here. 0 doesn't go with anything but 4, 2 only goes with 5, and 4 only goes with 6. And when we have that relationship with the numbers, where each x value has one and only one y value, then we have what's called a function. And the reason it's a function is because we say that the relationship is functional, and it creates a line whenever we graph it. That's one of the ways that we are able to determine if it is a linear equation, is it a function. Now, what happens if we have a situation like this, where we have, 4 and 7, that's in our domain, our x values, and then we have a value over here, let's say it's 2 in the range, and both the 4 and the 7 have the same y value. Does that matter? No, it doesn't matter, because it's all about the x. The x, 4, still only has one y value, and that's 2. And the x, 7, still only has one y value, and that's 2. But if we have a situation where we have, here's our domain and our range, and we have, let's say we have 3, 5, and 7. And over here we have 2, 4, and 6. And we map out that 3 could be 2. You could have an x value of 3 and a y value of 2. Or you could have an x value of 3 and a y value of 4. 5 has the value of 4 paired with it. And then 7 has 6, but then 7 also has 4. This is not a function. This does not create a straight line on the graph. We call this a relation. It is not a function. So we will remember that for a relation to be called a function, the domain must be specified or implied. So we have to know what the domain is, number one. Domain is specified. And that could be through the use of specific characters or letters or a formula or an equation. Number two, the way must be designated to find every pairing. Now, something that you need to remember is that sometimes in mathematics, when we talk about the y value for x, these are not called results or answers to the linear equation. These are called images. Okay, so we have the x value. The image of the x value is the y value. So a way must be, how am I going to say this? A way must be designated to find every image. So we must designate every image. So there has to be a pair with everything. All right, you can't have numbers over here that don't have a pair. So that's why this is relations, because every single image in the range has a pair with it. Okay. And number three, there must be one image for the domain. Only one image, which is the y, for the domain, which is the x. Okay? So that's how we can tell the difference between a function or a relation. And a relation, think parabola, circle, anything that's not a function that can be proven by the straight line test, that's going to be a relation. All right, so let's do some practice problems. So let me give you some illustrations. All right, in 94.1, we're going to look at example A. Which of the following of these depicts a function? We have A, B, C, and D. So in A, 4, which is the domain is always on the left, range is on the right. 4 has only one answer, which is 3. So you have 4 and 3. And 3 has only one answer, which is 3. So you have 3 and 3. So this equals a function. Okay. Now let's look at B. 7 has a value of 7 paired with 3, or I should say 7 has a value of 3 paired with it. And then we have 5, which has 3, but then 5 also has 4. So this is a relation. It is not a function, because the x value here is duplicated. We have 2 points that have the same x value. What about C? Well, we have that the x value of 4 is paired with the range or the image of 5, and then the x value or the domain of 6 has the y value or the image of 7. But then we also have an x value or a domain of m, but there's nothing in the y value or the range. M does not have an image that it's mapped to. Therefore, this is a relation. It is not a function. So B and C so far are not functions. What about D? Well, we have the set of all real numbers here, and then we have a formula. So we have any number we want to choose and a formula that gives us one result that pairs with whatever number we choose. So D would equal a function because we could pair every single x that we select with a y value. All right? So that's how you can tell the difference and how you can label them. So let's talk about the definition of a function. A function is a set of ordered pairs in which no two pairs have the same first element and different second elements. So that means your x value cannot be repeated, but your y value can be repeated. So that's what we're going to be looking for in our sets to determine which ones are functions and which ones are not. I'm going to put some more sets up here for you to look at. All right, in example 94.2, we just have to look at the points and determine based on the points which ones are functions and which ones are not. So the only thing we have to really do is look at the x values and see if any of them are duplicated. So that's a 4, 7, -3, -6. Those are all different. Therefore, A is a function. All right, let's look at B. We have 4, 5, 7, and 6, all different x values. Therefore, B is a function. C, we have a 5, 4, 7, and 5 again. Because the 5 is duplicated, C is not a function, it is a relation. And if we look at D, we see we have 7, 3, 6, and 4, all different x values. So D is also a function. And that is all you really need to do to tell the difference between a function and a relation. Is just look at the x values within the set of points that you're given or within the diagram illustration that you have. And that's all we have for lesson 94. I'll see you in lesson 95.